So this is basically Electrostats. I found a better book. That's what I think. This is David, I think Griffiths. David J. Griffiths, exactly. David J. Griffiths, Electrodynamics. Introduction to Electrodynamics. Okay. The cover I'll show if anybody wants to read. This is the book. So, yep. Okay. We need to zoom in a little. Yeah, ठीक है तो यही है इलेक्ट्रोस्टैटिक्स इससे बेटर आई फील इज बीइंग डन एंड पर्सनली उस बुक के अंदर थोड़े जो टर्म्स यूज हो रहे हैं एंड द सिंबल्स दैट आर बीइंग यूज्ड आर क्वाइट unfamiliar to my human brain. So chapter 2 electrostatics from Griffiths. Let's continue. And I also think the resource here is much better because again it is more suitable to me, I believe. But let's go for it. I might be wrong or I might be right. Who knows? Let's go for it. So, electrostats, electric field, introduction. The fundamental problem electrodynamics hopes to solve is this. Figure 2.1. So what does this figure show? Our source charges or test charge. We have some electric charges Q1, Q2, Q3 and so on. Call them source charges. What force do they exert on another charge Q, which is let it be test charge. The position of the source charges are given as functions of time. Okay, so ये position fixed नहीं. They are varying as functions of time. And they are telling that the trajectory of the test particle is to be calculated. In general, both the source charges and the test charge are in motion. मतलब अभी के लिए what they have shown is कि एक question हमें दिया है, एक problem statement दी गई है कि there are some source charges which are roaming around with some as a function of time हम लोग को दिया रहेगा and test particle का जो charge का trajectory है वो निकालना होगा बेस्ड ऑन द इलेक्ट्रोस्टैटिक फोर्सेस जो ये सोर्स चार्जेस टेस्ट चार्ज पे लगाएंगे उस कारण तुम्हारा टेस्ट चार्ज मूव करेगा ओके बट एक और क्वेश्चन इसके बाद आ जाता है लाइक लेवल 1 प्रॉब्लम है तो लेवल 2 आएगा कि बोथ द सोर्स एंड टेस्ट चार्जेस आर टू बी इन मोशन तो थोड़ा सा कॉम्प्लिकेटेड हो जाएगा बिकॉज इट विल इन्वॉल्व बोथ इलेक्ट्रोडायनेमिक्स एज वेल एज रोटेशनल मोशन के एंगुलर कॉन्सेप्ट्स लाइक एंगुलर मोमेंटम कंजर्वेशन समथिंग लाइक दैट मे बी ओके Maybe, I'm just saying, हो सकता है नहीं भी लगे. The solution to this problem is facilitated by the principle of superposition, which states that the interaction between any two charges is completely unaffected by the presence of the other. मतलब interaction दो charge के बीच में is unaffected by presence of others. दूसरे charges के present होने या ना होने से दो charges के बीच में जो force लग रहा है वो बदलेगा नहीं. जैसे Q1, Q2 उनके बीच में जो फोर्सेस लग रहे हैं अगर मैं Q3 लगाऊं या नहीं लगाऊं Qn लगाऊं या नहीं लगाऊं और उनको हटा भी दूं तो कोई फर्क पड़ने नहीं जा रहा है इट विल एट द एंड ऑफ द डे नॉट डिपेंड ऑन इट ये है प्रिंसिपल ऑफ सुपरपोजिशन इस पे कुछ क्वेश्चंस भी जेई में आए हुए हैं व्हिच स्टेट्स दैट इंटरेक्शन बिटवीन एनी टू चार्जेस इज कंप्लीटली अनअफेक्टेड बाय द प्रेजेंस ऑफ द अदर दिस मींस that to determine the force on Q, we can first compute the force F1 due to Q1 alone, ignoring all the others. Then we compute the force F2 due to Q2 alone, and so on. Finally, we'll take the vector sum of all the individual forces F1, F2, and so on. So if we can find the force on Q due to a single source charge Q, we are in principle done. This result, the rest is just a question of repeating the same operation over and over and adding it all up. ठीक है तो बेसिकली बात कह रहे हैं कि एक बार we can find the force on charge Q due to a single source charge Q. We can just do it for the rest of the charges. मतलब अगर Q1 के द्वारा F1 निकल आ रहा है तो you can just repeat the process for F2, F3 and it becomes a computational programming process और आंसर हमारा हम लोग निकाल सकते हैं. We are in principle done. The rest is just a question of repeating the same operation over and over and adding it all up. That's obvious. Now, well, at first sight, this looks pretty easy. Well, मेरे को तो नहीं लग रहा because I have a background with electrodynamics. Why don't I just write down the formula for the force on Q due to Q and be done with it? Well, I could, and in chapter 10 I shall. अरे यार ये बंदा बहुत अच्छी लैंग्वेज यूज करता है यार. This feels not just like a theory book है जैसे अगर मैं वापस जाऊँ elements of electromagnetism, this feels like a theory book यार from equation 4.15 और ये 00H and something like that. But इसके अंदर तो यार it's like the person is talking to me. That's fine. That's nice actually. Griffith, wow. Didn't expect this. It's like a fiction story book, थोड़ा बहुत. क्योंकि fiction में आप पढ़े होंगे. If you have read books from David Walliams, or maybe someone from, you have read books from David Walliams or somewhere in the book ranges where you find, I have forgotten the name. What was the name? The Lucky Boy or the Unlucky Boy, that kind of book. I don't remember the name, but it was a big series of books, and they are fiction books, but it's a comic book, and they are quite good at it. They're really good at it. It was one of the books that I really loved to read when I was in my 8th or ninth grade, I remember. Or maybe in early stages as well, 7th or 6th years. It was quite a good book to read. तो यार अच्छा लगा मेरे को, मज़ेदार चीज़ है. Why don't I just write down the formula and be done? I could run chapter 10, I shall. But you would be shocked to see it at this stage. For not only does the force on Q depend on the separation distance r between the charges, figure 2.2, it also depends on both their velocities. I'll take a moment right now. Few chapters that we need to. Okay, so I'm back. Where were we? We were at this point. Yes, so it also, for not only does the force on Q depend on the separation r between the charges, figure 2.2, it also depends on both their velocities and on the acceleration of Q. Okay, ये थोड़ा नया है कि it does not only depends on कि r distance, it also depends on the velocity and acceleration. Moreover, it is not the position, velocity or acceleration of Q right now that matters. Electromagnetic news travels at the speed of light. So what concerns Q is the position, velocity and acceleration Q had at some earlier time when the message left. They are talking थोड़ा सा massive scale में, मतलब light years के scale पे या बहुत ही light years तो थोड़ा ज़्यादा हो गया, light hours के या light minutes के scale पे, it's a very big distance of r that they are talking about. So basically Q का जो position है, what concerns Q is the position, velocity. Q is the test charge, ठीक है, is the position, velocity and acceleration of small q, which is the source charge, which had at some earlier time जब message left किया. A point is कि देखो इसके अंदर they are saying कि it's not instantaneous. Obviously बात है, हम लोग assume कर लेते हैं instantaneous है because speed of light पे message travel कर रहे हैं. But here they are saying कि यार instantaneous नहीं है, it will travel at the speed of light. But अगर distance is quite large है, like sun earth distance, तो उस केस में it will depend कि Q का small q का जो source charge है उसका position क्या है when message left, because that is what matters ना. message जब जहाँ leave किया उस position पे कितने force लग रहे हैं और कैसा हो रहा है. Actually this is a problem that we'll have to deal with in I think future questions, तो वहीं इसको better समझ में आएगा. Cool, so आगे बढ़ते हैं. Therefore, in spite of the fact that the basic question, what is the force on test due to Q's source, it is easy to state it is not paid to confront it head on. Rather, we shall go at it by stages. ठीक है, तो ये जो force एक दूसरे पे लगा रहेंगे directly conclude नहीं कर सकते हैं. दिस इज व्हाट दे आर ट्राइंग टू से. इसको कंक्लूड करने में लगेगा मेहनत, बिकॉज या हो सकता है कि डिस्टेंसेस कम हो तो थोड़ा बहुत कर सकते हैं, बहुत लंबे डिस्टेंसेस हैं तो उसके लिए अलग कुछ करना होगा, मेनी ऑफ द थिंग्स. और वेलोसिटी एक्सेलरेशन ये सारे फैक्टर्स जब आएंगे तो और भी बड़ी हो सकती हैं चीज़ें. इस कारण भी गो एट इट बाय स्टेजेस एंड नॉट हेड ऑन कि सीधे आंसर बताओ यार. इट इज नॉट दैट सिंपल. In the meantime, the theory we develop will allow for the solution of more subtle electromagnetic problems that do not present them in quite this simple format. Acha, the theory we develop will allow for the solution of more subtle electromagnetic problems. ठीक है, more easier, that do not present themselves in quite the simple format. Okay, to begin with, we shall consider the special case of electrostatics. तो सबसे पहले we'll study electrostatics, in which all the source charges are stationary. Name suggest करता है, though the test charge may be moving. So this is an important point. Electrostatics में the source charge is at rest with respect to the outer universe, or with respect to an initial frame of reference, inertial frame of reference. So electrostatics deals with electric effects of static charges, static source charges basically, which are at rest with respect to an inertial frame of reference. The test charge may be moving or may not be moving, and we'll consider the effects of these source charges on the test charges and what happens throughout electrostatics will be dealt. ठीक है, आगे बढ़ते हैं यार. Long introduction, very long. Deep introduction as well. It's already 12 minutes. Mathematics. What is mathematics? Coulomb's law. Okay, here we are. Okay, this is smaller as well. This is real smaller. It is running. Acha, magneto as well will come in user point of view. Okay. This is a good book. Seems. Okay. Coulomb's law. What is the force on a test charge capital Q due to a single point charge small q that is at rest at a distance r away? ठीक है. तो टेस्ट चार्ज कैपिटल Q है, and source charge small q है, point charge है. They are at a distance of r away. What is the force? This is answer based on experiments is given by Coulomb's law, which states it is 1 by 4 pi epsilon naught q by r square r cap. अब ये थोड़ा समझेंगे. The constant epsilon naught is called indecroissly. पता नहीं क्या है मतलब इसका. The permittivity of free space. It is called the permittivity of free space. In SI units, when for forces in newtons, the distance is in meters and charge is in coulombs. Epsilon naught की जो SI unit के अंदर values है, it is 8.85 10 to the power minus 12 coulomb square per Newton meter square. It's not in SI units, but ठीक है. In other words, वैसे है SI units में kg meter per second square करके उसको कर सकते हो वैसे. ठीक है, MLT minus 2 ऐसे ही सोचा जाता था ना न्यूटन को खोल के. Okay, in words, the force is proportional to the product of the charges and inversely proportional to the square of the separation distance, which is r in this case. As always, section 1.14, r is the separation vector from r dash, location of q, to r, location of capital Q. मतलब basically small q capital Q पे force लगा रहा है. तो r is what? जो ये वाला r है या कहाँ गया, ये जो r यहाँ लिखा हुआ है, यस ये r क्या है, ये जो r वेक्टर है, इट इज पोजीशन वेक्टर ऑफ कैपिटल Q माइनस द पोजीशन वेक्टर ऑफ स्मॉल q. वही यहाँ पे दे रखा है r माइनस r डैश. दिस इज यूजिंग बेसिक वेक्टर अलजेब्रा. ठीक है, एकदम बेसिक वाली चीज. इसका मैग्नीट्यूड इज r and its direction is r cap, and r cap is its direction. The force points along the line from small q to capital Q. If it is repulsive if small q and capital Q have the same sign, and attractive if the signs are opposite. Perfect. Coulomb's law and the principle of superposition. अब आ जाते हैं Coulomb's law and principle of superposition. They constitute the physical input of electrostatics. Physical input of electrostatics हम लोग यहाँ पे देखने को मिलता है. Okay, I don't know what that means. Coulomb's law and principle of superposition constitute the physical input of electrostatics. Okay, the rest, except for some special properties of matter, is mathematical elaboration of these fundamental rules. ओके, तो बेसिकली अगर मैं बात करूं तो इलेक्ट्रोस्टैटिक बॉइल्स डाउन टू टू थिंग्स, Coulomb's law and principle of superposition. Coulomb's law and principle of superposition are the basic things that constitute electrostatics, and except for some special properties of matter, everything that we'll be dealing with will be just a mathematical elaboration of these concepts, and we'll be using the amazing manipulations in throughout this journey. Electrodynamics. Okay, so basically, let's do it one more. To electrostats boils down to two things: Coulomb's law and principle of superposition. And Coulomb's law and principle of superposition के सारे mathematical aspects का मैं अगर elaboration करूँ using manipulations, I'll get all of the things that are in electrostatics except for some special properties of matter that we'll study. Okay, G. Let's do some problems. 12 equal charges Q are situated at the corners of a regular 12-sided polygon. ठीक है? For instance, one on each numeral of a clock face. What is the net force on test charge Q at the center? This is obvious. देखो, अगर कोई भी क्लॉक का आप देखे हो तो एवरी नंबर विल हर एक नंबर के उल्टा एक दूसरा नंबर होगा, तो आंसर 0 है इसका. दैट्स नॉट अ वेरी कमाल का क्वेश्चन. Suppose one of the 12 Qs removed, the one at 6 o'clock. What is the force on the Q now? तो वहाँ पे एक प्लस क्यू माइनस क्यू यूजिंग सुपरपोजिशन विल गेट 0 एंड माइनस क्यू के द्वारा विल गेट एन अट्रैक्टिव टुवर्ड्स डाउन, तो के क्यू क्यू बाई व्हाटएवर इज द मतलब डिस्टेंस का स्क्वायर आ जाएगा वहाँ पे. लाइक अगर मैं बात करूँ एंगल क्या होगा, तो 2π/12 दैट इज π/6 30 डिग्रीज. तो एक हमारा ट्राइंगल बनाओ 30 डिग्रीज का, ये है, ये हमको डी चाहिए और डी साइन थी, डी साइन 15 डी tan 15 सॉरी into 2 is your side length s. So d और tan 15 क्या होता है, √3 - 1 by √3 plus 1, तो 2 minus √3, तो 2 times 2 minus √3 is s. तो तुम्हारा distance d will be s by 4 minus 2 √3, which is a easy value to calculate. 3.4 से कर लेते हैं, अगर हम देखा तो s by 0.6 which is approximately कितना 5/3 5s/3 उतना तुम्हारा डिस्टेंस हो जाएगा d जो को स्क्वायर करना है. अगेन now 13 equal charges q are placed at the corners of a regular 13 sided polygon. What is the force on test charge q at the center? यहाँ मजा आना शुरू हो जाता है because यहाँ लोग विजुअलाइज नहीं कर पाएंगे एक्चुअली हो क्या रहा है. Let's break this problem into simpler problems. Triangle, क्योंकि इवन में तो दिख जाता है कि एक दो अपोजिट है, कैंसिल हो रहा है. ट्राइंगल 3 है. अब यहाँ काम आ जाएगी लामीज थ्योरम, जो जो वेक्टर अलजेब्रा में पढ़ते हैं. इट स्टेट्स कि इक्वल एंगल पे अगर इक्वल फोर्सेस लग रहे हैं एंड दे आर मेकिंग अ होल 2π एंगल, अगर सारे एंगल्स को मैं ऐड करूं एडजेसेंट बीच बीच के, देन उनका समेशन 0 होता है. तो अगर ट्राइंगल है उसमें भी 0 है, पेंटागन में भी 0 होगा, तो 13 वाले में भी 0 होगा. तो अगर एक्स्ट्रापोलेट करें तो 13 में इसका आंसर 0 होगा. If one of the 13 Qs is removed, what is the force on Q? Again plus Q minus Q कर दो, तुम्हारा आंसर आ जाएगा. अगेन सेम चीज को रिपीट टेलीकास्ट की तरह चलाया जा रहा है. अब क्या होगा, D का डिस्टेंस तो वो निकाल लेते हैं. अब जो एंगल बीच में बन रहा है वो कितना है, 2π/13, तो एक साइड π/13. अब ये जो D चाहिए, इसका D tan π/13 times 2 is your what S is, और D is S by 2 tan π/13. अब यहाँ से मैं आंसर निकाल सकता हूँ. I'll just have to use what a scientific calculator. I don't know how to calculate tan π/13 at the current stages. Okay, so we are done with here. That is the basic introduction for electrostatics, and the questions are there. We have studied Coulomb's law, electric field introduction, and begun chapter 2 of electrostatics. So that's it for this snippet, and I'll begin with the next one as soon as I get my time.